And we are in Module 6B for college algebra, and we've been working on inequalities. And what we saw last time is that inequalities can be linear, and we solve them the same way as we solve a linear equation. However, because it's an inequality, it has an infinite amount of solutions, and we have to draw a number line. And then the biggest feat that we had to get over is the fact that we could write the answer two different ways. We could write it in set builder or interval notation. So what we're going to do today is we're going to talk about not one inequality, we're going to talk about two. And two inequalities is called a compound inequality. So let's go to our notes. Okay, this is your definition. A compound linear inequality is two inequalities written as one statement using the word and and or. It relates totally to English class. You all know what a run-on sentence is, right? It's two sentences connected with the words and, but, or. Well, I'll tell you right now in math, we don't talk about people's butts. So we don't use the word but in math. But we will use the word and or. And just like in English, those words make a difference as to what the sentence means. So when you use an English sentence and you use and or, it makes a difference. So it's going to make a difference in math. First of all, and has a symbol. And if you look very closely at the notes, it looks like that upside down U. That's the mathematical symbol for the word and. The word or has a symbol, and it's the letter U. So we're going to talk about the words and or and what they mean. And to do this, we're first going to relate it to English. So let's go up to the whiteboard. Okay. Now, I want to make this make sense, so we're going to go back to an English class. I have two sentences connected. They're the same two sentences, and all I did was change the connecting word. And that word's going to change the meaning of the whole thing. So let's look at this compound sentence. I am a singer, or I am good looking. Well, what does that make you think of? Well, when you hear the word or, it should make you think of two different sets of values. The first sentence says, I am a singer. Well, can you all name a singer? I'm sure you can. Okay, I don't know what kind of music you listen to, but just to play along and have some fun, when I hear the sentence, I am a singer, I think of Bon Jovi. That's my favorite band, just so y'all know. You may think of Leanne Rimes. Okay? You may think of Beyonce. Okay? So we all can conjure up thoughts when I hear I am a singer. Think of a singer. It says, or I am good looking. Now that word or means this is set, has nothing to do with this set. So when I hear the word I am good looking, I can think of anybody. Do they have to be a singer? No. I could think of I am good looking, Brad Pitt. Or I could think I am good looking, Jennifer Aniston. Or I could think of that, J-Lo. So the word or means you have two different sets and you're putting them together. So the word or is uniting. So we say an or statement is a union. You're uniting two sets of answers together. So if I said to write me, I am a singer or I am good looking, whoever you named here in this set that sings and whoever you named here in this set that's good looking, that would be the answer, them together. But guys, watch this. I am a singer and I am good looking. Now we change the connecting word to and that changes the whole meaning. And means there are not two different sets. It is what these sets have in common. And something in common is an intersection. So not only do I have to name a singer here, but I have to name a singer that is also good looking. So in Miss Black's world, that would still be John Bon Jovi. He sings, he's good looking. In your world, I don't know, maybe that is Beyonce. I am a singer and I am good looking. Okay, so we got to be very careful between these words. Or means two different sets of answers we're going to unite and put together. And means what they have in common. They have something that's intersecting, overlapping in common. You could think of this. I can name a singer like Steven Tyler from Aerosmith, but he is not good looking. So he couldn't be the answer to this sentence, but he could be the answer to this one. I could put I'm a singer, Steve Tyler, or I'm good looking, because it's not implying both. So I hope that helps you out, because that's what this whole section's about. This whole section's not about the math, it's really about the English, the word that's going to be connecting. Now, to start you off, let's start off simple with some math. I have a compound inequality. Two inequalities connected with a connecting word. And if you look, that word is the key. And is always going to mean where these guys intersect, what they have in common. Or is going to be we're going to unite or make a union of the two different sets of values. So, there's no work to be done here. I've already solved this. X is less than 4 has already been solved. X is greater than or equal to -2 has already been solved. But what they want you to do when you have a compound inequality is they don't want you to draw two number lines, they want you to draw it all on one number line. And then you're either going to look for, if it's an and, an intersection, if it's an or, a union. So let's try this. X is less than 4. I'm going to go to 4. Less than goes in what direction? Very good, the left. Less than is not equal, so I put my parentheses. Then I'm on the same number line, going to go X is greater than or equal to -2. So I'm going to go to -2. Greater than is going to go to the right. So I'm going to color that up here. Greater than or equal to, it has an equals. So we'll put the bracket. You're not done. You didn't answer the question yet. This is the whole lesson, right here, that word. And means I want the intersection. What numbers these sets have in common. And if you look, that intersection is right here in the middle. That's where the two overlap. Here is listed all the numbers that are less than 4, and here is listed all the numbers that are greater than -2. So it's not looking at just here at the math, inequalities, and drawing them. It's looking at the connecting word. The connecting word is going to tell you what the final answer should be. This word and says, tell me where the intersection is. Now here's the problem. We got to write that. There's set builder, and there's interval. What you should have learned by now is interval is the easier way to write the answer. Because to write an answer in interval, you just look at the number line. Where does the shading begin for the intersection? The shading doesn't begin here for the intersection, it begins here. So that begins at -2 and it's got a bracket. Where does the shading end for the intersection? It ends here at 4 and it's got a parentheses. See how simple that was? So when you have the word and, after you draw your number line, you're looking for their intersection. Now, to write this in set builder, we use the fancy braces. We write X such that. The problem is here, how to write set builder. You cannot write in set builder X is less than 4 and X is greater than or equal to -2. There's a better way to write that. There's a better way to put that together as one statement. Think about it. What you just colored in are all the numbers in between -2 and 4, correct? So when you write an and statement in set builder, what you're going to do is you're going to show me all the numbers in between. The first number starts at -2, the shading ends at 4, and X goes in between because X represents your answers. So X is sandwiched in between these numbers. Now, you got to put symbols. There's a bracket on -2, which means there's an equals. There is a parentheses on 4, which means you don't put an equals. Now, if you look here, we got to put the inequality symbols. Well, this is obvious. We shaded less than 4. We shaded greater than -2. That's what we shaded. X is greater than or equal to -2. But if you look, the -2 is first, and the X is behind it. So we're technically taking this statement and flipping it over. And that's how we'd write it. Now let me explain to you what we just did. When you write the answer in set builder notation and you have the word and, you will not write this what you see up here. We'll never write the word and. Never will you see that word and in an answer. You will smush this together and make one big statement that looks like this. And how did I get that? Well, it comes from looking at the number line. You're saying all the answers here are between -2 and 4. So that's why I put -2, and then I put 4. And I put x in the middle because it's in between them. What I physically did is take this statement, x is less than 4, and put it in that spot. See how nice it fits? I took this inequality statement, x is greater than or equal to -2, and I put it in this spot. But to put it in this spot, I got to get the -2 on this side. So can you physically imagine flipping that over? And when you flip that statement over, in your head, this inequality flips over. So this is how you write the answer. It is read, -2 less than equal to x less than 4. In regular, everyday terms, what you're just saying to me is, hey, all the answers for x are in between -2 and 4. Just like in interval notation, we always write smaller number, bigger number, left to right. When you write set builder notation for an and statement, you're going to write smaller number, bigger number, left to right. And if you just want to memorize something, you might as well memorize it. Every time you write an and statement in set builder, the symbols are going to be less thans. Always. They're always going to point less thans. So that's how you write an and statement in set builder. It's very easy to write it at interval. Now, watch this and statement. Again, I have a compound inequality. I have 2. I'm going to draw both because they're already solved. X is less than -4. So here's -4. Less than is to the left. There's no equals, so it gets a parentheses. And x is greater than or equal to 2. I'm going to go to 2. Greater than goes to the right. It has an equals, so it gets a bracket. So that's the picture. And a lot of you will stop right there and say, that's the answer. No, it's not. The key is this word. And means what they have in common. Where do they intersect? I'm asking you guys, will you give me a number that's less than -4, and at the same time, the number has to be greater than or equal to 2? Well, does that number exist? Can a number be smaller than -4 and at the same time bigger than 2? No, it can't. And if you look at the picture, is there an intersection? No, there is no intersection. So the answer to this compound inequality is no solution. There is no answer. This can't happen. You can't be a number less than -4 and at the same time greater than 2. It can't happen. So that would be no solution. And no solution is both set builder and interval notation. So if you look, guys, when you're working with the compound inequality, it's not just taking the two inequalities and drawing the number line and being done. It's then looking at the connecting word. And always means look for the intersection. Now we're going to do or. Or does not mean an intersection. Or meant two different sets of answers. I could be a singer, or I could be good looking. So I could put Steve Tyler here. He's a singer, but I wouldn't put him here. Good looking could be Cindy Crawford. Well, she's not a singer. She's a model. So it's important that or means there's not one set of answers, there's two, and we're uniting them, bringing them together. So let's go to this picture. X is less than 4. So I'm going to go to 4. Less than goes to the left. And it doesn't have an equals, so I put my parentheses. X is greater than or equal to -2. So I go to -2. Greater than goes to the right. It has an equals, it gets a bracket. Again, you're not done. The picture's not the answer. This is the key. What does or mean? Or means unite everything you shaded. This is not an intersection. And means find where they meet in common. Or means unite. You have a blue set of answers and a red set of answers. Well, if you unite the blue and the red, if you look closely, you will see you colored in the whole number line here. So if you unite this, you colored in the whole number line. And the way you write that is, what do you call the numbers on the number line? Very good, they're called reals. So in set builder, we write X such that X is all real numbers. And to write that in interval, the shading starts at -infinity and it goes to +infinity. So it's not drawing the picture. It's looking at the word and telling yourself, do you want an intersection? I'd have the word and, or do you want to unite the picture what you shaded? Let's look at our last one here. X is less than -4. So I go to -4, less than is to the left. There is no equals. I put a parentheses. X is greater than or equal to 2. I go to 2. Greater than goes to the right. It has an equals. It gets a bracket. We're looking at the word or now. Or means unite. So the answers aren't just on the left side. The answers aren't just the right side. It's both. You're going to unite it. If you look closely, did we color in the whole number line here? No, we didn't. This part is blank. So we wouldn't say all reals. We didn't color in the whole number line. So in set builder, there's your brace, X such that. In set builder, you have to write this as two different answers because there's two sets. And you would just copy exactly what you have here. You would write, I colored in, Miss Black, X is less than -4, or X is greater than or equal to 2. So in set builder, because or means you have different sets of answers and you have to take both of them because you have to unite them, that's how you write an or statement, as two different sets. To write that in interval, because there's two different sections shaded, you'll write two intervals. So this shading starts at -infinity, and it only goes to -4. But guys, you have another shading, so you can't leave that one out. Or means you unite, you take both sets of answers. So this shading starts at 2, and it has a bracket, and this shading goes to +infinity. Now, the only thing extra you have to do is connect these two intervals. Like here, we connected the two inequalities with the word or. In interval notation, you want to put the word or here. But you don't use the word, you use the symbol, which is the letter U for unite. Now, we did a lot. We're not finished, but I just want to make sure everybody understands. The whole key to today's lesson is the word. And means after you're done drawing the number line, you're looking to see if they intersect. Or means when you're done drawing the number line, you're looking to unite what you colored. Over here, when you unite what we colored in the whole thing. That's why we said all reals. On this number line, we didn't color in the whole thing because these numbers are not colored in at all. So we colored in the numbers less than -4, greater than or equal to 2. So that's why we have two inequality statements, and that's why we have two intervals to show these two sets. Alrighty, now we're going to put it all together. Now what we're actually going to do is we're going to actually do the solving and go through everything. All right, so let's go back to our notes here and get a good example to work. All right, so we have 4x minus 2 greater than or equal to 14, or 3x minus 4 less than or equal to -13. If you all look closely, this is a compound inequality. It's not one inequality, it's two. Now we actually have to do the solving because x is not by itself. So we're going to just use our rules and solve each one. We're going to get x by itself, so we're going to add 2 here. 4x greater than or equal to 16. We're going to divide by 4. Do we switch the symbol? No, we do not. We're dividing by a positive, so everything stays put. But we're not done. We have another inequality to solve. Now, there's a connecting word. This word is the key to all the math, so I'd circle it. Because that word at the end is going to tell us what we're looking for. I'm going to go over here and solve. I'm going to add 4. 3x less than or equal to -9. I'm going to divide by 3. Am I going to switch the symbol? No, I'm not. I'm dividing by a positive, so the symbol stays. Okay. And I'm going to bring down this word. So I have two inequalities. That's why it's called compound. You're going to draw one number line. Okay? I always put 0. I'm going to draw this one first. It says x is greater than or equal to 4. So I'm at 4. Greater than goes to the right. It says equals. So what symbol? Bracket. All right, now I'm going to go to negative 3. Less than obviously goes to the left. It has an equals, it gets a bracket. Everybody good so far? So the solving is easy, the graphing is easy. The hard part is writing the answer correctly. Because number one, there's two different notations. There's set builder and there's interval. The key is this word or. Or means you want to look for the union. You want to unite what you shaded. And guys, I would write that word next to the word or so you know when you're done, what are you looking for? You're looking to unite. You're not looking to see what they have in common at intersection. You're uniting the answers. So you have a red set of answers and a blue set of answers. You don't go eeny, meeny, miny, mo. You take all of it. In set builder, we always write the braces with the X such that. Because you have to take both, you have no work. Your answer's up here. You're going to take both of these inequality statements. Remember, set builder uses the inequality symbols. So you're going to write both of those. X is greater than or equal to 4, or X is less than or equal to negative 3. You're done. So when you unite an or, I didn't color in the whole number line because these numbers in the middle are not part of the answer. I have two different sets. I write both. Now an interval, that has to do with following the number line from left to right. So I start on the left. Where does the shading begin? Negative infinity. How far does it go? Well, that shading only goes to negative 3. But wait, there's another shading. I have to unite. I have to take both. So this next shading begins at 4, and it goes to positive infinity. And there needs to go the word or here. But in interval notation, we don't write the word or, we use the symbol, a U. 99% of the time, an or is going to look like this. Your picture of your number line is going to be two separate areas shaded. You're going to have those two inequalities written in set builder, and you're going to have two intervals written. Only one shot out of 100 does the or overlap, and that's when it is all reals. All right, let's try one more. Okay, we did an or, so obviously we need to do an and. So our last example in this set is 1 less than or equal to 2x plus 3 less than 11. All right, first of all, it's compound. There are two inequality symbols, but you do not see the connecting word, correct? I agree with you. There is no word up there. What you've got to understand, and I know it's a lot of memorizing some facts now, when we write an inequality, a compound inequality with the two symbols here, this is always connected with the word and. We won't see the word and. In fact, you'll never see the word and. You'll never see the word and in an answer. You'll never see the word and written. You're going to understand when I read this out loud, this is read, 1 less than or equal to 2x plus 3 and 2x plus 3 less than 11. I can physically break this up to be two statements. And the way I do that is I take what's in the middle and it belongs to both. So if you cover up the 11, there's your first inequality. 1 less than or equal to 2x plus 3. And if you cover up that number, 2x plus 3 less than 11. Do not take what's in the middle and separate it. This in the middle goes to both the number 1 and the 2x plus 3 goes to the number 11. That's how you make the two inequalities. And because you don't see a connecting word, it's understood to be the word and. Now we're going to solve them. I'm going to subtract 3. Negative 2 less than or equal to 2x. I'm going to divide by 2. Negative 1 less than or equal to x. And we know we can't draw that without the x on the left side. So if I flip that over like a flapjack, that really says x is greater than or equal to negative 1. I'm going to go over here and solve. I'm going to subtract 3. I'm going to get 2x is less than 8. I'm going to divide by 2. I'm going to get x is less than 4. The key is this word. What you got to remember about the word and, it means I'm going to be looking for an intersection. when I'm done. So let's draw a number line and see if we get an intersection. Okay? So first we're going to go to -1. It says greater than. Okay, greater than -1 goes to the right. Equal to -1 gets the bracket. On the same number line, I'm going to draw x is less than 4. So again, here's 4. Less than 4 goes to the left. And there's no equal, so it gets a parentheses. So that's your picture. Now here's the catch, guys. Everything is based on the word. The word tells you whether you're looking to unite the picture or only look for the intersection. And means intersection. So if this was me, if I saw the word and, I'd write, all right, I'm looking for an intersection. So now we can write our answer. In set builder, where is the intersection? Well, everybody look closely. The intersection is from here to here. Y'all with me? Now, it's much easier to write the intersection in interval notation because we could see it. Where does that intersection start at? It starts at -1 with a bracket. Where does that intersection end at? It ends at 4 with a parentheses. You're telling me all the numbers they have in common are between -1 and 4. Think about it. Think of a number greater than -1. I'm thinking of 0. Is 0 also less than 4? Yes, it is. So that's what an and means. You're finding a number that makes both of these statements true. It works for both. Writing an and statement in set builder is a pain. You cannot write in set builder x is greater than or equal to -1 and x is less than 4. You'll get marked wrong. You never write the word and. So when you write the answer in set builder, x such that, you put the numbers you're in between. The smaller number is -1, the larger number is 4. You put x in the middle of that because that's what you're saying. I colored in all the numbers for x that are in between -1 and 4. Now look what I'm doing. I'm taking this statement, x is less than 4, and I'm sliding in here. X is less than 4. I'm taking this statement, x is greater than -1, and I'm sliding in here. But I don't have the x first, I have the -1 first. So I'm really taking that it's, when you flip it, there. And if you look at the symbol, -1 less than equal to x. -1 less than equal to x. So to write an and statement, you always put the letter x in between the two numbers it's sandwiched in the intersection, smaller number, then bigger number, and these symbols are always less thans. So you have a lot of work now to do to practice because it's not the solving and it's not drawing the number line. It's looking at the word and or and deciding, do I want an intersection or do I want a union? Okay, see you in the next module.